I believe we are on, gentlemen. Hello, everybody, and away we go again into space with the SBAU Astro Hour. I'm Ronnie Herron on behalf of SBAU, the Santa Barbara Astronomical Unit of Santa Barbara, California, with our 248th program from Monday, September 29th through Sunday, October 5th, 2025. The gentleman on the Zoom screen around me and I will be kicking around these cosmic topics this week. We're going to spot the rest of our family of planets for you. For example, Mercury is buried in the sunlight. Venus rises just before dawn. And the rest of them, Mars, Jupiter, the other gas giants. Speaking of before dawn, when's the best time to see zodiacal light? Well, there you have it. First quarter moon's about to happen right before 5 o'clock. We're going to focus on one of its 100-mile wide craters, Maginus. And back in late January, NASA's Psyche mission captured multiple images of stars, planets, even the Jovian moons. How about the rotation rate of Uranus? Well, we're going to recommend a good proctologist for that.
It's official. We're calling it Doug from now on.
That's right. I thought about that. We better call it Doug. You're absolutely right. A force from empty space. It's called the Casimir effect, caused by quantum vacuum, something we all know, but we're going to talk about it anyway. Ties in with old-time clipper ships, coming attractions, double slit experiment, dreaded light waves or particles. That's in the future. Let's meet the gang, shall we? Let me tell you, first of all, our fun club's headquartered at the museum. Dr. Filipenko will be in town to talk to us. He's an old member from 50 years ago, and he graduated DP High, and that's this Friday. Star Party will be the second Saturday up at the Museum of Natural History. And Astro Hour, number 240. Doggone. Here he is, once again, on his way on a vacation. Jerry Wilson, beloved president. Have you stopped counting the years? Is it 7, 8, 9? Do you have any idea?
No, I have no idea.
I want
to say hello. I want to give a shout out to my sister Joyce, my grandsons Calvin and Riley.
Well, can you tell us, are these people you're giving shout outs to watching our program?
My sister usually is, and I believe at least one of my grandchildren regularly watches it.
Wonder how many of your homeowners that attended that daytime thing you got invited to talk to your homeowners.
Oh, I have no idea.
Well, I don't either, but I guess
I noticed our viewership, which is logged by YouTube, has been increasing.
Oh, I imagine. I know a couple of people that watch. Pat Forgy is your beloved wife, supports her husband, supports the club, supports me. Mm-hmm. Here's our outreach guy. He's awesome. Chuck McPartland, in front of the Ukrainian flag, takes us everywhere. Man sets up those heavy equipment. God, hundreds of times a year. His wife is Pat McPartland, merchandise manager, as well as hardworking treasurer. Tom Whittemore joined us. He's married to Maureen. Yep. Edits our newsletter. Now opened a bakery in his home and formerly an instructor. I always smell sourdough bread, and I want some when you're on screen.
You got a good nose.
I know. I had one of your loaves years ago, and it still haunts me. Westmont College. I'm sure you have nightmare dreams about that. Bruce Murdoch signed in early this morning. He's married to Bonnie. Still runs the Santa Barbara Theater Organ Society and loves this stuff just like we do. And I guess he got logged in early enough to get rid of that dreadful feedback we used to get. I guess you're a little thinner on the screen than the rest of us, but that's okay. We love you, man.
Well, it's 2x4 rather than 9x16.
So the video. Your picture's coming from your iPhone, right, or your cell phone?
Right.
Got it. All right. Tim Crawford, resident lens and telescope expert, is going to be there Friday night.
How do you do?
Are you bringing Karen? Are you going to bring Karen to Friday night?
No.
Oh, okay. But you're going to be there.
Yep.
Tell me what it is, the Filipenko's you have. Is it a CD with a continuing series of lessons?
Oh yeah, he sent out CDs. It was just an entire course in astronomy. DVDs. I think that he offered to the public and probably offers it to the to students and all that stuff too. It's old though. It's an older version. I'm sure.
Well, I keep reading stuff on Google about him. I think he shares in a Nobel Prize, doesn't he, for
No.
physics?
No.
Shares part
No,
of
no,
it.
he
He was a
doesn't.
member of both teams.
Yeah, his
Right.
team won it, and the named people in it distributed the money to all the rest of the team,
I see.
even though they didn't get marquee space.
He's broken all kinds. He keeps setting records up at Berkeley. We do the silly science cartoons that are all forwarded in one lump these days from our beloved president. And I'm ready to talk about them, read them, let you guys read some of them if you want. These are the lightweight. This is a conspiracy theory or dedicated to the theorists. The moon landing was fake. They used CGI, which back in 1972 was Pong.
Yeah.
Yeah.
We all played Pong, but CGI, I looked them up. I couldn't find the what the letters stand for. All they said was it's a Canadian company, consulting firm.
It's computer generated images.
Images, yeah.
Oh, that's funny. So this 1972 would have been about 4 years before they were founded.
Now we refer to something like that as AI generated.
Oh yeah, that's true. I remember I used to play. Oh, we go back to double time. This is the dreaded, horrible words dinosaur, huge reptile predator showing up upon a couple of primitive cavemen who were way out of time on their era. Begin sprouting. Your lackadaisicalness is disadvantageous.
I didn't see that.
You all vamoose with great importunity. Oh crap! They say to each other, it's a thesaurus.
You know, the spotting feature for a thesaurus is it's pronounced gazetteer.
You say that again? I didn't get that.
The spotting feature for a thesaurus dinosaur is it's pronounced gazetteer.
Well, I know yesterday a very large, heavy thesaurus book fell out of the bookmobile downtown, and motorists were just mortified, chagrined, fearful, shocked, amazed, defensive. They were terrified. Oh, here we are. Guy's trying to pick up a girl. He leans into her window and says, "Yeah, I'm a mathematician." She says to him, "Okay, then name all the digits in pi." And he goes, 1, 2, 3, 4, 5, 6, 7, 8, 9. I guess she's driving away. Well, that's on me, I guess. I set the bar too low.
And he's a mathematician.
Yeah.
Is there a difference? What is that?
A mathematician.
It's a misspelling.
Yeah.
Oh, there is no. Okay, maybe.
Typo.
If he was doing the real pi numbers, he'd still be going, wouldn't he?
It never ends.
I know. When you buy a car from IKEA, this is what you got to do. You got to put it together yourself.
I like this.
Something I read about IKEA. They use 10% of the world's lumber. Did you know that?
No, I didn't.
Okay, here is that Schrodinger talking? Or
Yeah, that's Schrodinger, Irwin.
okay, and he's reading, you don't know if the cat is alive or dead inside the box until you look inside and it goes, meow, and shut up. Cut it out. If you guys want to read any of these, you want to explain you've done the Etch-a-Sketch, right? They have a gallery, a museum, and it was only a minor earthquake. It just totally ruined everything. You can't.
Oh yeah, yeah.
And here are the two Central American explorers coming up.
Archaeologist.
Oh yeah, right. Coming up on a Mayan ruin, one of their pyramids. Guy says to the other, "Fascinating, but why so many steps?" And there it is. The ancient Mayan playing with his slinky toy.
Him and Slinky.
Circa 450 BC. That's the reason. Okay, gentlemen, got a full house today. Let's talk cosmic stuff here.
Okay, this is the evening morning. What is this? Morning sky. It's 5:30 in the morning, and Venus has just come up. So this is the sky before dawn. This is in several places on the internet. They have the planetary roundup. That's what we're going through, showing where the different planets are.
Yeah, and Jerry, just to show everybody how much Venus has moved in about a week or so, it was right next to Regulus on Friday the 19th
Yeah.
of September, It is really diving.
So it's going to go from being the morning star to the evening star in a few
Mhm.
months or sooner. So there's a number of other things. This is Leo coming up in the morning.
Mhm.
Leo will be overhead in the late evening around February and March.
Mhm.
And this is the realm of galaxies where we're looking out through the North Pole of our galaxy. So you don't see the band of the Milky Way anywhere through this map here, or this display.
Mhm.
This is in the evening. See, we're now at the west. This is Mars setting. This is at 7:15 p.m. I did check, the evenings are getting darker, a lot lighter nowadays.
Yeah.
And so you could see this if you have a good horizon. I don't have a good western horizon here where I am, but you need a good one to be able to see this before before it sets.
Mhm.
Where from your house, Jerry? I'm surprised at that. It's what's blocking your west? The eucalyptus?
The fence.
Yeah.
Oh, okay.
No, the western is covered by some hills. We see, the coast along here is the oceans to the south.
Mhm.
Yeah.
And so looking west from here, we're looking at a series of low hills. And we see rockets go up from Vandenberg Air Force Base. They rise in the west for us.
Okay.
Come up over the hills.
Like
ocean
last night.
out for us.
So are you saying that after the fall equinox, the sky not only darkens longer, but better? We got better seeing in winter and fall than we do in summer?
Seeing is not the issue. That's atmospheric turbulence. But the sky gets darker a lot lighter a lot sooner in the evening.
Yeah,
Yeah.
the day is now changing by about 2 minutes roughly,
Yeah.
losing about 2 minutes each
Yeah,
day.
I didn't bother to set up a scope last night because Arcturus was just sparkly, sparkly.
Mhm.
Yeah. Yeah.
That's seeing, yeah.
Now this is
Mhm.
Jupiter. This is looking in the east. About 3 a.m. Jupiter has risen,
Mhm.
probably about 1 a.m. And it's getting up there.
Mhm.
Is there anything else in there? There's a lot of features around here. The Beehive cluster.
Well, that Jupiter's right next to the Eskimo.
Yeah, yeah,
Right.
right there. And the Eskimo is this. You might not be able to see this, that little magenta ring there.
Yeah.
And
Yeah.
then here's
Got
the
Orion in the upper.
I saw it come up.
Yeah, there's Orion
Yeah.
right there.
I also saw Jupiter come up. So it's dropped out of Gemini considerably. I know it's still in the quarter of Gemini, but it's during the summer, earlier in the summer, it was right in the middle of Gemini, the twins.
Up in
It's
here.
just falling down towards Cancer now, a
Yeah.
little bit at a time.
The one that I like is Hubble's Variable Nebula there. I still don't have a good star hop for that. It's harder than hell to find. Just hopping around.
Hubble's Variable Nebula?
Yeah, it's at that reddish area
See the red thing?
below the feet of the Gemini, to the right of Gemini.
Right. It's near the Rosette.
Right there.
Yep.
Yeah, although it's not that big, so that's actually probably the Christmas tree cone nebula area.
Mm-hmm. Mm-hmm.
But it doesn't have a Messier number?
No, it's
no.
too dim for Messier.
Oh, okay.
But in southern Utah, the Rosette is naked eye.
Wow.
Yeah.
Wow.
I forgot, when do we meet on this winter months down at the museum on second Saturday? Is it earlier than 6 or?
The
No,
11th. The next one's the 11th.
I'm
no, but
talking about-
we never start earlier than 7 p.m.
Oh, okay. Even though it's been dark a couple hours in
Yep.
February.
People come, but
Yeah, you got 47 yesterday and a cloud out.
That's amazing.
Huh.
That is amazing.
It's just me and Mike Jacoby.
Oh, okay.
Yeah.
There's a ring around that planet.
this
Ring
is really
round about.
really washed
It's
out.
washed out.
Oh,
Thought you were just being esoteric, giving us an artistic view of Saturn. There we go.
Better?
Okay. So this is a picture taken by Christopher Go from the Philippines. He does absolutely excellent planetary photography. And here, this is, it's in universal time, but the date is, that's the time. I guess you don't get the date, the date's down here. This is July 30. So it's a few months ago. It shows the very narrow rings. Last March, the rings actually were flat to us.
Jerry,
Really?
why in his astrophotography is the lower one so different than the upper one there? What did he do there?
Well, this is a longer photograph. This is 30 minutes. This is 14 minutes. This one, I don't know. But you can see the planet or the moon Rhea
Yeah,
here.
Rhea, yeah.
Well, I think he's trying to show the Seeliger effect. That's where, when it's near edge on, you get much more scattering back from the ring particles. And so they look a lot brighter.
Oh, okay. Okay.
That's when it's near opposition. So this one may be later. It's also, you can see CH4, so he's using a methane filter, the lower one.
Oh, yeah, I was looking for the filter ID, yeah. So this is white light, and this is narrowband for methane.
Oh, huh.
Methane filter. What does that mean?
Good spot, Chuck.
It's only passing the light from methane.
Yeah.
That's why the difference. That
Yeah.
I couldn't figure it out.
I didn't know Saturn had such bands like Jupiter.
Yep.
Well, did
See,
they-
CH4, I would have thought it just was
They've
on
also got
channel
very
4.
high wind.
well, Saturn
Yeah,
would
they've
float
also
in a
got
large
very
enough,
high wind.
Saturn would float in a large enough tub. Jupiter doesn't have that problem, right?
That's correct. But Jupiter also wouldn't leave a big ring.
I think we worked that one to death.
Yes, we did.
I
Okay,
like
here, the midnight sky shows Neptune and Saturn. You will be able to see Saturn with the naked eye, but up here for Neptune, you're going to need a telescope that's not naked eye. And this red splotch down here is Ceres.
Okay.
So, and this is the circlet of Pisces up here, and the Helix Nebula down there. I don't see anything else really. M2 is
Doug, right in the middle.
globular cluster. Yeah, okay. And this completes our tour of the planets for this month with Uranus, aka Doug, right between the Hyades, Taurus, and the Pleiades.
Planet Doug.
Yeah, Crystal Ball Nebula. I never heard of that one. Anyway, this is a nice, rich part of the sky. And again, you will not see Uranus with your naked eye, at least not from our skies. It's not quite as faint as Neptune, but it is, what is it, 6th or 7th magnitude? So anyway, if you look around in Santa Barbara, you're most likely going to see clouds.
Or fog.
Yeah. Now, this time of year, we can also see the zodiacal light. This time we will be seeing it in the morning. And this is a photograph of it. And it is, gosh, I forgot where it's taken. It is taken from the Canary Islands. These are, this is a ring, a plane of dust, like rings of Saturn, but there's a ring, this is a faint ring around the sun. And it is made up out of dust and crap coming off of comets. This one, recent research complains this, or pinpoints this dust as coming from Mars, primarily.
You know, Jerry, I thought that was a skateboard down below, but all of a sudden I realized it's a picnic bench.
Yeah.
Yes, with snow.
Yeah.
Yeah.
Must be high up in the Canaries.
Yeah, let's see.
And there's a lot of light pollution for the Canaries.
Mm-hmm.
Beyond Mount Tieta in the Canary Islands.
Well, are we looking at what's about to be the sunrise?
Yeah.
Yes.
Okay.
Now, what, Jerry? Why is Zodiacal light in the morning, in the fall? Is that what it?
Yeah.
Yeah, in the spring, it's in the evening.
Because
Huh.
it depends on the angle of the ecliptic to the horizon,
Mm-hmm.
making it easier to see.
Yeah.
Okay.
And you can see the Andromeda Galaxy up here
Yeah.
Mm-hmm.
and the Milky Way going through here. And so this light is about the same brightness as the Milky Way is.
Hmm.
That's interesting. I didn't know that. Okay. The angle of the ecliptic.
Yeah.
Mm-hmm.
The moon, Alice.
So the moon, that was a cartoon a while ago that we had. That these two astronauts are walking on the moon and they come to a woman's body on the moon. And one guy kneels down and looks and he says, "Why, it's Alice Cramden."
Yeah, yeah.
One of these days, Alice, pow, right to the moon. If you watch The Honeymooners back in the 50s.
Oh
Yeah.
yeah, you'd never get away with that type of intimidation in today's
No.
world.
No, things were much more violent. The cartoons back then were very violent, especially the Tom and Jerry ones.
I wasn't a crazy fan of Gleason. I thought he was a jerk, pushy jerk. He could be funny, but I didn't consider him the great one.
Yeah, I didn't watch that show. I didn't like all the yelling and screaming back and forth.
Yeah,
He
I
had-
like Red Skelton.
Yeah, yeah.
Oh, yeah. He laughed at his own jokes.
Yeah, that's fun.
Yeah.
He did jokes about the two seagulls, Heathcliff and something or other. Heathcliff, I forgot the other seagull's name, but he had all these crazy. They're now called dad jokes, but they were pretty funny.
Wasn't he credited for like early meme or mime or mimes? Because he did a lot of the stand-up stuff where there would be imaginary people around him.
Mm-hmm.
No,
Well, he was Clem Cadiddlehopper.
there was
Yeah.
that one. Yeah, the hobo.
Yeah, there was a lot. They
And
still
he
play
was,
those time and again on Sirius Radio. So
Yeah. And he was the mean widow kid.
yeah, yeah.
The hobo was Freddie.
Yeah.
Oh yeah, Brady the Freeloader.
Clem would turn his hat upside down, I think, and just. I have one.
Okay,
of those
well,
now.
coming back from nostalgia lane,
Yep, but that's good stuff though.
the first quarter moon occurs this week, and I believe it occurs today.
Oh,
And so in that region of the moon, this is the southern highlands down here, and it's a lot of craters. And among that, the square is blown up here because there's a what's called a sunrise ray that you can see. And this is the crater Meginus. And you don't need much of an imagination, but there's a notch in the crater wall here. And the morning sun comes and it produces this triangular shaped ray that as the sun rises, this ray starts out here and the point slowly moves toward the wall.
huh.
So it's a feature like the for lunatics, it's a feature like the lunar X and stuff, other features. There's a lot of the human brain loves to make patterns out of random noise and clutter. We call it UFO sightings, but but it makes all sorts of things. There's things that look like scissors and eyeglasses and all sorts of things on the moon. We had a rundown of that about 2 years ago. We can cover that stuff again. It's really interesting. Okay.
Well, stupid question time for me.
Yeah, go ahead.
The same rocks from space that they say gave us our oceans that are loaded down with water hit the moon, but only on the poles did the water stay. Otherwise, the water that would have been what there in the crater for a while would have steamed off into space with the sunlight. So that's why the moon doesn't have any water except on the places where the sun don't shine.
Or trapped in the minerals, yeah.
Right.
Yeah.
Do they think they're like ice lakes in the base of these polar craters, or is it just mixed in with the the lunar soil?
Yeah, it's B.
Yeah.
Okay, but it goes
A
into
bee.
space. All that water is out there still in space. Is that what makes nebula? Some of it
Water is all over the place, and it's produced in novas. There's a lot of water out there. There was a secret project, I forget the name of it, in World War II, where Britain was considering making very large aircraft carriers out of a material called pykrete, which was water ice mixed with sawdust. And the
It was
stuff,
Project Habakkuk.
what's that?
Project Habakkuk.
Okay, thank you. And the stuff is very, very tough and very slow to melt, and it floats. But that's the kind of stuff, if you mix the ice with soil, a regolith on the moon, instead of sawdust, because there's no sawdust on the moon, you'll get a similar material that's all mixed up there. But it looks like, to a spectrometer, the reason that they figured that there's water on the moon in some of these craters was based on data taken by the Clementines spacecraft, a joint operation between NSF and the Air Force. And they went over and they spotted hydrogen. They were using radar and they got a signal back from hydrogen. And so they figured, oh, that could be water. So they didn't see anything, but they got these signals back, and other spacecraft have confirmed it. And we worked on where I worked at Santa Barbara Research Center, we worked on a proposal.
So what you're talking about is something like hard icy mud, right?
Yes,
Frozen
yeah,
mud.
very similar, yeah. And so we worked on a project to try and look inside those craters with far infrared radiator light cameras, and wanted to see the nature of the ice, but we didn't get funded for that project.
Well, we have that here on Earth called tundra.
We have permafrost, yeah.
Yeah, permafrost.
We
right.
have atmospheric pressure here, which the moon doesn't have. And that's what causes the ice on the moon to sublime and go away. I once went to the research labs in Albuquerque. In the morning, I went into the lab, Sandia National Labs, and there was snow on the ground, snow and ice, because it had snowed overnight. And when I came out in the afternoon, the snow was completely gone, but the ground was not wet. In Albuquerque, the humidity is so low that the snow had sublimed back into the atmosphere.
Without leaving the ground wet.
Yeah. Okay. So there's also another crater combination that is, let's see.
Herschel, named after the astronomer.
His son.
Oh,
His son is
yeah.
John.
John Herschel.
He was also an astronomer, but
And Philohaus.
what? Another astronomer?
I don't know that name.
Philosopher.
another scientist or philosopher, yeah.
But while the previous picture was in the, this is where the Terminator is this coming Thursday. So this is past first quarter. So gibbous moon, because the Terminator will be now shaped like this. You can see it there. And this is in the other end. This is in the North Polar region of it, up near Marcrisium.
The Bay of Rainbows there, Sinus Iridum. They spelled it wrong at the bottom.
Yeah.
Some of these wrong spellings are actually foreign spellings. So, but I have seen a lot of typos in this. So anyway, these are at low light levels near the Terminator like this. You can see these pressure ridges, these ripples in the surface.
Yeah, Chuck is right, Jerry. Chuck's right. Iridium is an element.
Oh, yes.
Iridium is or isn't an element?
It's an element.
Iridium
Yeah,
is an element, but this is
Right.
sinus
Iridium,
iridium.
iridium is the possessive,
Yeah.
Latin possessive.
Okay.
they used to make phonograph needles out of iridium because it's very hard.
Well, it was left behind on the Earth by the asteroid that killed the dinosaurs, I heard, a layer.
Yeah, a
Yes.
layer of it.
Because it's more common in asteroids than on the Earth. This is Plato with a little detached notch there. So a very good spotting feature.
Not to be confused with Play-Doh.
Yeah.
Plato, yeah. Now, this is an interesting picture.
Wow.
This was taken by the planetary probe called Psyche, and it's heading for Psyche, the asteroid. And it's got, turned around and took a picture of the Earth and the moon right there. This is a blow up of that showing the Earth. And
Wow.
so they're testing the camera. It's in the constellation of
Aries.
Looks like Aries.
Yeah, that's why RE is here. These are different stars in RE. So, and so it got that picture, and then it also took this picture. Nope. Oops.
Wow.
We're talking about the Psyche mission, the NASA mission here.
Yes.
Yeah, the Psyche mission. I'm going to go back. This one has lost track of where we are.
Uh-oh. That's not good.
No.
Uh-oh. Wasn't exactly Sagan's little blue dot. At least it wasn't covered.
That was a resolved, yeah. Well, it was bright. Remember, the size of things you see are due to brightness, not their actual size usually. And here you can see that the blown up picture of Jupiter has a, what is that, an octagonal side here?
Yeah.
That's because that's the shape of the diaphragm, the camera housing. It's not the shape of the object. It's just a bright object. But we know it's Jupiter, Io, Callisto, and Ganymede. So this is another calibration shot in Taurus that it went through. And this was taken on January 30th of this year, 5-second exposure. And this
And
one,
where have all the stars gone? Well, there's some in there, but you can barely see them.
oh, it didn't take a long enough exposure to get many stars.
Is that right?
Yeah.
The planets are
The
brighter.
longer
Planets are a lot
the camera
brighter.
opens.
Okay. It's one of the things I keep learning.
Okay. Now, these are some cool images. These are images taken by the Hubble Space Telescope of Uranus. And the thing that we're looking at here are aurora and storms on Uranus, on Doug. And these are auroras here. Now, the auroras, like on Earth, are a property of the magnetic field generated by internal structures on the planet.
Not incoming radiation from anywhere.
No, it is incoming radiation, but where it can come in is determined by the magnetic field here. So the magnetic field, if it has a uniform enough field, it can be like a dipole. And so it has an offset. This is to the sun. By measuring the rate of rotation of the aurora, it can determine the rate of rotation of internal parts of Uranus under the atmosphere. With the cloud tops, the only thing that we are looking at usually, it's very difficult to decide if we're looking at the rotation rate of 300-mile-an-hour winds of the surface, or we're looking at the actual planet's body itself. So this was a research paper that was attempting to find the rotation of the internal structure of the planet. And that is, turns out it has a rotational period of 17 hours, 14 minutes, and 52 seconds. Now, Jupiter, you know, has a rotation period of about 10 hours. And so these big guys are spinning pretty fast.
Wow. For some reason, I always thought we were looking at the South Pole or the North Pole from the bottom or the top, but we're looking at its side, tip of its
No,
side.
this is a magnetic thing, like plus and minus, North Pole and South Pole, where the rotation axis is right here. And so that would be then to the sun. So one of these would be the north, the true north, and one of them would be the true south.
Well, the Earth has that too. Our magnetic pole is over Greenland.
Yes.
Is it really? Is it moved there?
Yeah.
It's for all your what do they call them?
14 degrees
Compass.
off the true north
Yeah,
Damn.
from us, from where we look at it.
for the Earth. Yeah.
Right.
This one really was, it was just beyond me, Ronnie. This is the one that really got me. I didn't get it. But you're saying, Jerry, it's an internal rotation.
Yes.
Yeah, you know, because you could have winds in the upper atmosphere that are blowing along like jet stream winds.
Uh-huh.
It would give you a value much higher than what's necessarily happening below.
Okay. And now did they figure the internal rotation by this study using magnetics?
Using
Yes.
where the aurora appeared.
Yeah.
Well,
The
yeah,
aurora
the
is framed by
result of the magnetic.
Okay. That makes sense. Good.
But now that I look at this, I was right the first time. If the sun is off to the left, we're off to the left, and we are looking at the bottom.
We're looking at what?
Well, I just said that we're looking. I thought what we're looking at here is the view we would get.
Yes.
Our angle, but the sun is off to the left, and we're back there. We're to the left too.
Yes, that's right.
We're down near the sun. Therefore, we're looking at the south pole of this planet, and I guess the north.
Well, Ron, that varies as it goes around its orbit. You know, when it's at its equinoxes, we would be looking at the equator of it. We don't always see it as a bullseye, for example.
Oh.
So it changes, and all areas of the planet's surface see the sunlight sooner or later.
Yeah. Long seasons.
Okay.
If any sunlight gets through the clouds, yes.
Yeah.
It kind of like outside right now,
Yeah.
huh?
But here you can see what they did over a period of 10 years was they measured the aurora and they got the rotational speed for the aurora, which gives you the rotational speed of the internal dynamo.
Internal, yeah.
Yeah.
Interesting.
The white and the blue mean something there, I guess. Huh?
Yeah.
Methane.
Oh, can you enlarge this, sir?
Yes. I was just
Here we go, Ronnie. This is where I went from not knowing to really not knowing.
You can't tell me about the Casimir effect? Well, I can
Uh-uh.
tell you. Oh, hell, I know all about this.
I read it and didn't get it.
Well, the ship analogy is a really good way of understanding it.
Yeah.
Yeah.
Now what happens here is if you take two plates, two polished conductive plates, say aluminum or silver or something, and you put them in a vacuum and you take all the air, everything out of it, you get a really good vacuum. There is a slight force, a weak force, where these plates start trying to move together. And the reason that it's trying to move together is because outside there's more room for longer wavelength quantum mechanics. This is one of the effects that the reason this is here is because even though Newtonian mechanics was very successful and we use it without correction in our space probe navigation, getting to Mars, it gets us there perfectly, close enough. There are quantum mechanical effects, and there are some quantum mechanical effects that you can make show up in our macroscopic world. One of them is It just escaped my mind. Oh yeah, we'll discuss it next time, the double slit experiment that
Oh,
yeah.
great.
led
Great,
us
great.
to the wave particle duality, and makes the world really in capital letters a what
Yeah.
type of thing. So and the phrase, yes, your theory is crazy, but is it crazy enough to be right? So anyway, what's happening is that these two plates have a force between them that pushes them together. And there are fluctuations in the vacuum field. The total vacuum anywhere in space or in our lab, wherever you make it, it is not nothing. It is something.
Not
The vacuum
total.
of space here is space-time, and space-time is a flexible field. It can support waves, gravitational waves. So we know it's not nothing. And what happens is there are fluctuations from this thing, also called the 0 point energy, for example, just in the vacuum of space. Virtual particles, electrons and anti-electrons, will just all of a sudden come into being in the vacuum of space, last for a trillionth of a second, and then recombine. There was no energy supplied. They just pop out and then they go back again. And they're called virtual particles because they do not conserve energy and they do not conserve momentum. They're
What
like,
does that mean? What does that mean,
like-
recombine?
what?
You said recombine. What does that
Yeah,
mean?
they come out of the vacuum of space and then very quickly they go back in again.
Oh,
They
they
annihilate.
Yeah,
They annihilate each other.
but they don't release energy. The energy that created them is called the 0 point energy, and people have been struggling for decades to try and figure out how to tap this 0 point energy because it's everywhere. Our universe is filled with it. You won't need to take batteries along on a spaceship if you could tap the 0 point energy.
Oh boy. Wow.
Science fiction show I liked called Stargate SG-1. They're always trying to find the Z energy, 0 point energy. I guess it was a British definition. But these plates define boundary conditions for these 0 point for these vacuum modes of quantum mechanics. And there's many more modes allowed outside because there's more room. Inside, only a few things can fit. And so there are much less modes in here, much less quantum vibrations. And so the imbalance slowly drives the two things together. Now there's
So there's much less of nothing in the middle than the outside.
Yeah, kind of.
yes, that's right. But nothing is not nothing.
Okay.
Nothing is something.
Yeah, yeah.
What about out in those voids? You suppose that might be pretty close to pure?
This is what void is. Void is a elastic medium. It's like fish trying to understand water. You know, they're in it, but they don't consider it to be anything. So it's like when the wind blows, you can't see it, but you can feel it.
Yeah.
The
yeah.
vacuum of space, you can't see it, but you can feel the gravitational distortion of it. And it's 4-dimensional. So, space-time, it's space-time. And we're bound by it. We are part of it. We are folds in it. So let's see now. This is a picture of the types of fluctuations that occur in the vacuum of space. And there are larger ones that occur outside and smaller ones because they are the only ones that can fit in this region.
That's really overexposed.
Oh, is it?
It still gets the point across though.
Yeah.
Do you suppose there's some quantum entanglement involved? Is there a particle with its brother over in the other plate and they're all trying to get together? Maybe?
No.
Well, I don't understand what the plates are. Are they in a
They're
vacuum?
metal plates. They're conductive plates.
Yeah.
They're inside a battery or
No, they're inside of a vacuum chamber in a laboratory.
Oh,
Let's
I
say
see.
the plates are 1 inch by 1 inch square and a millimeter thick.
Huh.
Wow.
So,
that's
and
where
yet these
Kubrick.
plates attract each other. They've accounted for gravitational attraction. It's not that.
Do they move them closer and further away and have the same effect?
The
Changes.
effect diminishes the farther away you set the plates.
It would have to,
Now
wouldn't it?
you can fit bigger fluctuations in.
Yeah, yeah, it would have to. Yeah.
So
Boy, that's really neat. What would what would a heavy magnetism do, or electromagnetism introduced into this do?
these are not charged plates, so
Okay.
so
Okay.
it doesn't matter.
Okay.
This is an electric field, and this is a magnetic field. So it is electromagnetic radiation that is doing this fluctuation from the vacuum state into our universe and back again. And it's this idea that led Gamow, I think it was, to postulate a steady state universe where it's because evidence that it was expanding. We knew that from the time from what's his name? And he said, well, the universe is still, it's not static, but it's steady state. Because as it expands, new particles are created out of nothingness of space. So it keeps the density constant. It was a good idea, but it's not right.
Yeah.
So
Wow.
I lost my train of thought. Oh, but anyway, this is why they want to crack that the 0 point energy, because this is just, it's limitless.
It would be if, yeah, it is limitless, yeah, but you can't get it on this side of the curtain for some reason.
Yeah, we
Mr.
got to find
President?
that curtain, I think, the opening in the curtain.
If
Did I
there's a
miss-
little guy behind the curtain, just ignore him.
Pay no attention to that wizard.
Okay.
Did I miss what these plates are made of?
Silver, aluminum, whatever you want, as long as they're conducting.
Oh, even though you just told Tim that doesn't involve electro, they're conducting?
They are conducting, but they're not charged.
Okay.
They're neutral.
Person that made this diagram shouldn't have used H for the separation, because B equals mu H. H is the
Yes.
magnetic field.
And whoever
Yeah,
discovered
good
this,
observation.
That confused me when I first saw this.
the man who discovered this is an Italian named Casimir.
That sounds
He's
Polish.
the
to
first
me.
guy that figured out what it is. In physics, you get something named after you, not only for being the first to see it and say, hey, look at this, but also the first person to understand what it means. So you have to see it and say, oh, I know what that is. That's the guy that's going to get named after.
I wonder if this has anything to do with the Casimir sweaters, collecting electric.
That's cashmere. Yeah, no.
Yeah.
Okay. Now this is a photograph, a nano material photograph of a sphere on these on this spring, and this is a measurement of the Casimir effect.
Oh God! Wow.
There is a force between this sphere and this field down here, and they measured it with this structure.
Got to be an
Those are probably piezoelectric.
I can't hear you.
Those are probably piezoelectric, the supports. So
Yes.
they can determine
yeah, that's how they measure the offset. Yeah.
So this little nanosphere, Jerry, what is it made of?
I don't know in this case.
Okay, but it's pretty small.
It's probably just the common metals in this thing are gold, copper, aluminum. So it's probably one of those things.
Yeah.
But it's an electron.
there's a scale directly below it that shows you what 100 micrometers looks like.
Yeah. There's got to be a little teeny guy with a really small little measuring
This
tape.
is the boat analogy, and people notice this it is not the Casimir effect, but it is an analogous effect of ocean waves, that you can have the region between two boats parked together is like these are breakwaters, and it smooths it out. So there's fewer big waves between the boat, and there's the big waves are out here in the open ocean, and it provides a slight force pushing these boats together. In the case of warships back in the 1700s, they noticed this effect with warships next to each other. And they were always wondering about it. It is an analogy. It's a good way to understand it. But these are electromagnetic fluctuations in the vacuum of space, which is not nothing. It's something because it can wave. So this was a cartoon. My love, fate is drawing our boats together. And she said, haven't you ever heard about Casimir?
I like it. I like it. That is a good analogy. And something in my brain just went click.
Yeah.
But Mr. President, how does it apply to space? How often do you get two plates in outer space?
Every time you set it up in your lab.
So it only happens there?
Well, it happens wherever you have the situation set up for it.
Okay.
I've got to go back to the other way because this one is lost track of where it is.
That's neat. That was one when I read it, I just said, I'm going to have trouble with it, but that is neat.
Well, the test is this weekend, Tim. I'm cramming for it myself. To the sky.
Okay, this is Comet Swan taken by Adam Block at Mount Lemmon Observatory in Arizona.
Boy, if we were religious, that'd be an angel.
It was taken in the last few days, but I don't recall the exact time. I don't have it marked here. But I threw this in as a bonus thing because it's a really pretty picture. And you notice we have a green head. No green back here, but other dust and chemicals. The density of the coma up here is low enough that this green chemical does not relax back does not decompose by running into other molecules of the same type. So the distance
that's that dicarbon.
Yeah, thanks.
Carbon?
Yeah.
Now, this was a video that I could not successfully capture, but this is something that we could have seen the last few days. This is a recent photo of a detached prominence from the surface of the sun down here. And you can see the magnetic field lines curving up into it. I don't know if that's washed out or not, is it?
It
Yes.
is.
Yeah.
Wow.
And
Not this latest Sunday, but the Sunday before, Tim had a very good view of
yeah, we get these.
prominence.
We get these
Last Sunday,
Yeah, you were there, Jerry.
last Sunday, there was a long streamer coming off the sun.
Yeah.
Very large prominence. Is this better?
a little better, yeah.
Little?
Yeah.
That's a tough photo. But there's a lot of faint features here that show magnetic field lines going down, going up. And in the video, you could see things cooling off and then falling down along the magnetic field lines. But this is
Jerry,
a large.
For my information, when talking to the public, I just tell them, I've been telling them that these detached prominences is because the force of this prominence kind of separated from the surface. But that's not it, is it?
What happens is the sun is like a wad of rubber bands because the magnetic fields are not like electric fields. Magnetic fields do not start and end on anything. They're continuous loops. So it's like a rubber band, and you can stretch it and twist it and do all these things to it. But if you tried to make a ball out of rubber bands by just putting it in your hands and rubbing your hands together and rolling it up and stuff, you will get a ball of rubber bands, but rubber bands are always going to get tight and they're going to pop out of the surface because they're all twisted up beyond their sort of circular rest position. They're all torn and moved by the other rubber bands.
Yeah, Tim, that was known as the rubber band model of the sun, and they bounced the idea.
All right. That's
You are a card and need to be dealt with.
Yeah.
Okay, so anyway,
Good luck.
as you do this, a rubber in the sun, magnetic, it gets all twisted up, and magnetic fields are forced out of the sun. And then what happens is a magnetic field just rises out of the sun, and it tears the plasma with it. And as it gets up higher, the plasma cools off because the magnetic field orients the randomness of the plasma, and they cool off, they become visible, and then they fall back into the sun. So if you look, a prominence is coming up slowly, and if you could zoom in with a high definition picture, you'd see that it's really a flowing waterfall of solar plasma back down to the surface. So it's the magnetic field line that lifts up, and it tears plasma with it, because the plasma makes the, excuse me, I've said it wrong. The magnetic field makes the plasma move a certain way, and when the plasma moves, it makes a magnetic field. So it's a very complicated, and trust me, the math of that will drive you crazy. The field is called magnetohydrodynamics, and we studied it a bit in graduate E&M.
But you're calling it a prominence? This is not a flare.
This is a prominence.
Okay.
Yeah, Ronnie, a flare is a short-lived brightening that you'll see.
Yeah.
It's like an explosion. It's not the feathery stuff sticking off the sun.
Right. Sometimes when that magnetic field line comes up, more than one of them come up at once, and they are hooked to a large amount of plasma. And when that plasma comes out of the sun, it all of a sudden expands, and that's when you get a really bright flash. And then it blows all that stuff off. Sometimes the part of the sun that it has grabbed hold of is so big, and it breaks off, and it, like ball lightning, its magnetic field lines disconnect from the field lines in the sun, and the magnetic field lines break and reconnect. And when that does that, that releases a lot of energy. And so the plasma and its magnetic fields leave the sun. That's a coronal mass ejection. And it's a bright flash too.
What we call sunspots, is that involved with any of this?
Sunspots are when a magnetic field line loops around, goes out of the sun's surface and then loops around. And it's been like that for a while. And where it goes through the sun's surface, high temperature is disorder, random motion. The magnetic field line makes the motion not random anymore. So that cools the surface off. So right near the magnetic field line, the sun's surface cools, and it's lower temperature than the surrounding stuff, and to our eye, it looks black.
That's how you get the black.
The sun is very interesting.
One thing I've been mentioning to customers is that the sunspots kind of travel in pairs.
Yeah.
And these prominences, they'll pop out of one and travel to the other, because one is like north and one south. Yeah. But what here you're saying when these prominences can detach, and then they can fall like rain, just down.
No, that's a normal prominence.
Okay.
All prominences, the material is raining back down, and the magnetic field is losing its control over that. But some of them are so violent, the magnetic field line and the plasma form an Alfvén wave, and they become their own thing, and they break off from the sun. And when that first starts, you get a real bright flash, and that's the flare.
Okay, never seen one yet. I haven't seen one yet.
The sun is, we think of the sun as a planet made out of plasma, but that's not realistic. The sun is a magnetic field twisting itself up. And all the effects we see are the magnetic field lines trying to get happy with all the other magnetic field lines.
God.
Well, take one of these planes that made out of balsa wood, an airplane when you're a kid, and it has a propeller, and you wind the propeller up, and it's on a big long rubber band. Eventually, you wind it up, and you wind it up, and then you can get the rubber band is all wound up. And then you keep winding anyway, and now you see parts of the rubber band are popping out of the nice pattern, and they're making knots and stuff.
Yep.
That's exactly what a magnetic field line on the sun does. It gets all twisted up, and it can't do its nice circular loop thing anymore, so it gets all twisted up and gnarly. And that contains a lot of energy.
Now, just to be clear, it means that a prominence doesn't necessarily have to travel from one sunspot to another. It can just be a weakness in a sunspot or anywhere on the surface. And
Wherever these magnetic field lines come in and out, they may or not be intense enough to have made a sunspot.
okay, very good.
Can I ask, what is it that sometimes leaves the sun and starts coming toward us and screws up our
That's the
electrical?
coronal mass ejection that Jerry just mentioned.
Yeah,
That's a prominence that doesn't come back.
It's a wow big prominence that comes out with so much force and brings so much plasma with it that it just keeps going.
and it's hundreds of tons, Ronnie, hundreds of tons of plasma.
Well, does it get taken up by our polar electrical field?
Yeah.
And that
Oh
makes-
yeah, this
Even
is what
more-
causes the auroras.
Well, they're always there, aren't they? It's a real big aurora, I guess, if we get one of those suckers.
Yeah.
It's when the auroras come down to Santa Barbara and you can see them at night down here.
Yeah.
That's when you get
Whoa.
Yeah.
Oh yeah, the whole sky turns red or pink.
Yeah.
I saw that when I was a teenager.
What a way to end the show, guys. That's great.
Oh, that went by quick.
Yeah, it did. We do have a lot of fun with this, and I just wish I could retain it all. But this Friday night, Berkeley's Dr. Filippenko in town, and he'll speak to our October 3rd general meeting at the museum. We'll be back next Monday morning afterwards, 11 a.m. for another SBAU Astro Hour, everybody. Till then, there's only one way we can say farewell in astronomy, and that would be
Hasta Nebula.